Good morning, students. Today we are going to read the first lecture in the topic of air. That is a subtopic of atmosphere and environment. So our today's topic is air. So this is the first lecture of the topic. So concentrate yourself. We are going to start now. Composition of the dry air. Air is a mixture of the gases, elements, and compounds. Air is a mixture and not a compound because here are the reasons. This question frequently come in the paper and you have to give these reasons. Number one, its composition varies. Examples, oxygen is more soluble than nitrogen in water, although both solubilities are low. Thus, air dissolved in water contains 34% of the oxygen by volume instead of 20% present in the free air. This enriched air is of vital importance to fish and the marine animals for respiration. Air at a height of 20 km above sea levels contain 80% nitrogen and 19% oxygen. So the composition of the air varies. So that's why this is a mixture, not a compound. The second logic for this is it can be separated into its constituent by purely physical means. For example, by fractional distillation of the liquid air. The next proof for the point is it has the properties of its constituent. For example, like oxygen, it supports combustion. The next point for the proof is when the correct proportions of the nitrogen, oxygen, carbon dioxide, and water vapors are mixed together, no chemical reaction can be observed, and the mixture shows all the properties of the ordinary air. So that's why air is a mixture, not a compound. The air makes up the Earth's atmosphere, and it is essential for life on our planet. Table shows the composition of the dry air. So these are the composition by percentage. Nitrogen 78.03, oxygen 20.99, argon 0.93, carbon dioxide 0.03, neon 0.0015, hydrogen 0.0010, helium 0.0005, krypton 0.0001, and xenon 0.000008. So out of all these, 3-4 quantities are very important, which normally comes in the MCQs paper. That is nitrogen almost 78%, oxygen almost 21%, carbon dioxide is 0.03%. So you have to learn these three quantities by percentage especially. The content of the water vapor in the air varies from 0% in desert to 4% in our rainforest. So this is another very important point that you have to remember. The percentage of the content of the water vapor in the air varies from 0 to 4% from desert to rainforest. Here is a question: which of the following gases is most common in air? Although nitrogen is the most common gas, but the options are argon, carbon dioxide, oxygen, and water vapors. So out of these four, oxygen is the most frequent gas, is the gas that contains the highest proportion of the air. So C, oxygen makes up almost 21% of the air. The most abundant is nitrogen. The noble gases take part in few chemical reactions. Helium is used to fill airships. You have seen this kind of the airships. Helium gas is used. Argon is used in light bulbs. So these kind of the light bulbs used argon as a gas. A helium neon laser used in the eye surgery. So this kind of the eye surgery is a very normal operations nowadays. So helium neon laser is used. Neon and other noble gases are used in the illuminated signs. So these signboards which you have ever seen on the busy roads of your city. So the neon and the other noble gases are used in the illuminated signs. The next topic that we are going to read is the solubility of the gases. Life in water depends on dissolved oxygen gas. The amount of the oxygen dissolved depends on the temperature. And look at the graphs. So from the graph, this is the graph of the solubility of the oxygen gas, and this is the graph of the solubility of the carbon dioxide gas. So in these two graphs, you can see as the temperature rises. So here is the temperature on the horizontal line, and here is the mass of the gas insoluble in the water. So you can see as the temperature rises, the solubility decreases. So solubility is higher at the low temperature and lower at the higher temperature. So you can see that gases get less soluble as the temperature of the water rises. Look at the first graph. This is the thermal pollution of the water. This is the problem to aquatic life. So look at the second graph. Oceans are important in dissolving carbon dioxide gas, a greenhouse gas. So as the temperature rises, the water less gas is soluble in the water at high temperature. So it means the proportion of the gas, carbon dioxide gas, is getting higher in our environment because of the greenhouse gases. The amount of the carbon dioxide absorbed will be less by the oceans as their temperature rises due to global warming. Next thing that we are going to read is the fractional distillation, industrial preparation of the oxygen. Oxygen, nitrogen, and noble gases in the air can be separated by fractional distillation of the liquid air. These gases are distilled out at their different boiling points. So here is the fractional distillation, and here is a figure that explains the process. So here is the air that passed through a filter to remove dust. Then it will be cooled to minus 20 degrees C, remove water vapors as ice, remove carbon dioxide as solid, and carbon dioxide. Then it is passing to the next chamber, compresses to 100 atmosphere. Then it is passed to the next chamber, allowed to expand suddenly. The sudden expansion cools the air. Then it is passed to recycle the cooled gases. Then it is passed after many cycles of the compression followed by expansion. Some air liquefies. Then it is passed to liquid air at minus 200 degrees C. Then it is passed to minus 190 degrees C insulated fractionating column. Perforated shelves bring ascending and descending gases into contact at each level minus 200 degrees C. Then liquid oxygen boiling point is minus 183 degrees C. So here the liquid oxygen is obtained. And gaseous nitrogen, whose boiling point is minus 196 degrees C. So gaseous nitrogen is obtained. And the gaseous argon, whose boiling point is minus 190 degrees C. So gaseous argon is obtained. The fractions can be purified by redistillation. Oxygen, nitrogen, and argon are stored under pressure in strong metal cylinders. Okay, here you can see the process by another figure. Dust-free air is pumped into the plant. Carbon dioxide is removed by bubbling through an alkali. Then water is removed in a drying tar. So this is the same process which you have seen in the previous figure. So this is the simple. Gases are compressed to 200 atmosphere. Expansion of the gases. Repeated compression and expansion of the gases. Liquid air to a fractionating tar. Then nitrogen gas and oxygen gas is obtained. The next thing that we are going to read is the table of the boiling points of the some gases is shown below. So these are very important as far as your paper number 1 is concerned. Nitrogen's boiling point is minus 196 degrees C. Argon's boiling point is minus 186 degrees C. Oxygen's boiling point is minus 182 degrees C. And krypton's boiling point is minus 153 degrees C. So you have to learn these boiling points. The next thing that we are going to read is the oxygen laboratory preparation. Hydrogen peroxide is often used as the source of the oxygen. It decomposes to give oxygen and water. So look now, here is the hydrogen peroxide. It is decomposed to give oxygen and water. And here is the figure. Manganese oxide is used as the catalyst. Hydrogen peroxide solution is here. And oxygen gas is bubbled out. So this is the apparatus. But safety first. You can use this apparatus, but you must wear safety glasses. To speed up the reaction, you can either warm the solution or add a catalyst. The catalyst manganese oxide MnO2 is often used to speed up the process. And here is a video for the preparation of the oxygen in the laboratory. So that will make your concepts more clear now.
Using hydrogen peroxide. Hydrogen peroxide is a colorless, heavy, strongly oxidizing liquid. Its chemical formula is H2O2. It is highly unstable. It is used in the preparation of oxygen gas in the laboratory. Set up the apparatus as shown here.
This is the apparatus.
Some manganese dioxide and water is taken in a conical flask. Hydrogen peroxide is added dropwise through the thistle funnel. You will see that the oxygen gas comes out through the delivery tube. Oxygen gas is collected by the downward displacement of water.
So I hope so this video will be helpful in making your concepts more clear. How the oxygen is prepared in the laboratory. Or oxygen can also be prepared in the laboratory by the action of the heat on potassium chlorate, potassium manganate, mercury oxide, sodium nitrate, or potassium nitrate. The next thing that we are going to read in the lecture is physical properties of oxygen. There are several known allotropes of the oxygen, including O2 and O3. It is a poor conductor of heat and electricity. It is a colorless, tasteless, and odorless gas. It is only slightly soluble in water. It is slightly dense than air. It supports combustion and life. So these are the physical properties of the oxygen. So learn them because questions of 2 to 3 marks frequently come from this topic. Oxygen is a reactive gas in the air. So here is a test that we can see here. Oxygen is used up when things burn or when we breathe. Remember the test for the oxygen, and here is a test for the oxygen. A glowing splint relights. So if we bring a glowing splint into the container of the oxygen, it will relight. And here is a video that will make your concepts more clear. So here you can see. So the students are bringing the here you can see. So this is the test for the oxygen gas. Okay, the next thing that we are going to read is the reactions of some elements with oxygen. Here is the element, observation, product, and action of the product on water. The element, that is copper, observation, does not burn, turns black. Product is copper oxide, that is CuO, black solid. And action of the product on water, it is insoluble. Now we are going to read the reaction of the magnesium with oxygen. The observation is burns with a bright white flame. Product is magnesium oxide MgO, that is a white solid. And action of the product, that is magnesium oxide on water, is dissolved slightly to give an alkaline solution pH 9. Next, iron's reaction with the oxygen. Observation is burns with yellow sparks. Product is iron oxide, that is Fe3O4, a blue-black solid. And the action of the iron oxide on water is insoluble. The next is the reaction of the sodium with oxygen. Observation is burns with a yellow flame. Product is sodium oxide, that is Na2O, yellow-white solid. And the action of the Na2O on water is dissolves readily to form a strongly alkaline solution, that is pH 10. Reaction of the sulfur with oxygen. Observation is burns with a blue flame. Product is sulfur dioxide, that is SO2, a fuming gas with a choking smell. And the action of the SO2 on water is dissolves readily to form a strongly acidic solution pH 2. Now, the action of the carbon with oxygen. Observation is glows red. The product is carbon dioxide, CO2, an invisible gas. And the action of the CO2 on water is dissolves slightly to give a weakly acidic solution, that is pH 4. Next, the reaction of the phosphorus with oxygen. Observation is burns with a yellow flame. The product is phosphorus oxide, that is P2O5, a white solid. And the reaction of the P2O5 on water is dissolves to give a strongly acidic solution pH 2. The next thing that we are going to read is oxides. A basic oxide is one which reacts with an acid to form a salt and water only. And here are some examples. CaO plus 2ACl. So this is a basic oxide. So when it reacts with acid, forms salt and water. Another example is CuO. When reacts with H2SO4, it forms a salt, that is copper sulfate and water. The next point is, if a basic oxide is soluble, it forms a hydroxide with water. So here is the basic oxide, that is CuO. When it is dissolved in water, it forms hydroxide. The oxides of most metals are basic metals. They are mostly solids. Na2O and K2O soluble, whereas iron oxide and copper oxide are insoluble. The next thing that we are going to read is the acidic oxide. Reacts with a base to form a salt and water only. And here is the acidic oxide, that is CO2. When it reacts with a base, that is NaOH, it forms a salt and water only. Soluble acidic oxides dissolve in water to form acids. So look here, This is the acidic oxide. When it is going to be dissolved in water, it forms acid. That is SO3 plus H2O forms H2SO4. So this is acid. They are generally oxides of the non-metals. Many are gases, some are solids, and some are liquids. For example, CO2, SO2, SO3, P2O5 are soluble, whereas SiO2 insoluble. The next thing that we are going to read is the amphoteric oxides have properties of both basic and acidic oxides. For example, Al2O3 and ZnO. Reactions of the zinc oxide. So first we are going to see its reaction as a basic oxide. So it reacts with hydrochloric acid as follows. So it is behaving like a basic oxide. So when it reacts with acid, so it forms salt and water. And when it behaves as acidic oxides, it reacts with a base to form salt and water. So ZnO plus 2NaOH plus H2O forms acid. The next thing that we are going to read is the neutral oxides. Neutral oxides have neither acidic nor basic properties. And here are the examples: water, N2O, NO, and CO. And here is the figure that will make your concepts more clear. So here are the oxides, elements. So some are metallic elements and some are non-metallic elements. And when they combine with oxygen, some forms metallic elements forms oxides of the metallic elements are bases, most are solids. And non-metallic elements, when react with oxygen, they forms oxides of the non-metallic elements. Many are gases, some are liquids, and some are solids. So here is the point to be remember: metallic elements forms bases, and non-metallic elements forms acids. And bases are some dissolved in water, these are alkalis, and some bases are insoluble, whereas most dissolve in water to form acid, and some are insoluble as neutral. A pattern can be seen in the nature of the oxides. See the figure above. The oxides of the metallic elements are bases. If the bases dissolve in water, they are called alkalis. The oxides of the non-metallic elements are mostly acids, but some are neutral. Acids react with bases to form salts. When an element or compound combines with oxygen, we say it has been oxidized. Oxygen oxidizes carbon to carbon dioxide. This reaction is an oxidation reaction. So look now, the oxidation reaction of the carbon. Carbon plus oxygen forms carbon dioxide. The opposite of the oxidation is reduction. When a substance loses oxygen, it is reduced, or this process is called reduction. So this was the lecture, students. I hope so this will be much more interesting and easy for you to understand. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.